Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the File Upload Vulnerabilities module titled Remote Code Execution via Web Shell Upload. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on File Upload Labs, and select lab number 1 titled Remote Code Execution via Web Shell Upload. Alright, let's get started. This lab contains a vulnerable image upload function. It doesn't perform any validation on the files users upload before storing them on the server's file system. To solve the lab, upload a basic PHP web shell and use it to exfiltrate the contents of the file /home/carlos/secret. Submit the secret using the button provided in the lab banner. You can log into your own account using the following credentials, and we're given credentials for a regular user. Alright, so the target goal over here is to exploit the file upload vulnerability so that we could upload a PHP web shell, which will allow us to exfiltrate the contents of the secret file. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Okay, the first thing we're going to do is click on my account and log in with the credentials that we were given. So the password was Peter, hit login. Now notice over here, it gives us the option to update the email address or upload an avatar image. Now, whenever there's an upload functionality, you definitely need to test it for file upload vulnerabilities, because these vulnerabilities tend to be critical since they usually give you remote code execution on the server. And that's exactly what we're going to do over here. Now, the first thing that we're going to do is go to Terminal, New Terminal in Visual Studio, and just create a test image. So let's say touch test.jpg. Now we're going to upload that image. So it's under other locations, computer. Here we go. Hit select and then upload it. Now notice over here it says the file avatar/test.jpg has been uploaded. So if we go over here and look at the request that was responsible for the upload, you could see over here it's a post request to the /myaccount/avatar endpoint. And then it takes in a request, and over here is the file that we uploaded. Now there's no content to the file because it was simply an empty file. So we're going to send this request to repeater because we need to test it for file upload vulnerabilities. The next thing we're going to do is see how we could call this file that we just uploaded. So since it was an avatar image, you should be able to call it from over here. It was empty, and that's why it has the default image over here. But if you right click and then say open image in new tab, you could see that's where it would display the image. So this request is also important to us because that's how we're going to get to execute the web shell that we uploaded. So let's go up and hit enter again. And that might be filtered over here. So let's select that, hit apply, and here we go. So here's our image. So let's send this one to repeater as well. All right, so what we're going to do over here is see if the application allows us to upload something other than a JPEG or let's say a PNG image. So if we hit send over here, you could see that the application is using the Apache server, which supports multiple languages. Now, in a real world scenario, what you would do is fingerprint the server to try and identify which technologies it has the ability to execute. In the exercise, it already does that for us, and it tells us that we can upload a PHP shell and the server is able to process a PHP shell, likely because it was built using the PHP language. So that's exactly what we're going to do. We're going to go over here, click on File, New File, and create a test.php file. Hit Create File. And what we want over here is a PHP script that allows us to run any command that we want on the system. So not just the command that outputs the secret file. So to do that, we'll start off by initializing it. So it's PHP, and then we're going to use the system function to say, I want you to run this system command. And the command we're going to get from the URL parameter. So it's from a GET request, and it's from the CMD parameter in the GET request. And this will make sense in a bit. All right, let's close that off. This looks good. Let's save it. Now, what we could do is we could upload it through here, or we could just simply upload it from the browser. So I'm just going to upload it from the browser just because it's easier. So it's test.php over here, hit select, click on upload, and you can see over here it says it has been uploaded. Go back to the account, and then let's visit the PHP shell that we just uploaded. Click on open image in new tab. Now over here, it displays nothing because we don't display anything in our PHP shell. But what we could do over here is add our parameter CMD. So we'll add it right over here. CMD is equal to, and now we could run any command that we want on the server. So let's say, who am I? So you could see that the application is running with Carlos privileges. We could say hostname, hit enter. This is the host name of the server. And now let's just output the content of the secret file. So it was cat. And I don't remember the exact path. It was home/Carlos/secret. So let's put that in here. Home/Carlos/secret. Hit enter. And here we go. This is the content of the secret file. Let's copy that. Click on submit solution, put it in here, click OK. And we get congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Now, before we script it in Python, let's send the requests that were responsible for uploading the PHP shell. So it was this one right over here. Let's send that to repeater. And this one right over here to execute our web shell. So let's send that one to repeater again. And let's put this in here. Close this for now and start working on our Python script. Okay, the first thing we're going to do is import all the libraries that we're going to need. So import requests, that's responsible for performing the HTTP requests. Next, we'll import sys because we need to take a few variables from the command line. And then we'll also import URL lib3, and from BS4, import beautiful soup. This will allow us to parse the responses. And then we'll also import random string, and from requests to belt, import multi-part encoder. And this library will allow us to perform the request for uploading the avatar image. All right, next let's disable insecure requests warnings. So disable warnings URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy setting because we want all of our requests to be sent to Burp. So all HTTP requests should be sent to HTTP 127.0.0.1 port 8080. And I wrote that incorrectly. That's where Burp is running. And then same goes for HTTPS requests. They should be sent to where Burp is running, which is HTTP 127.0.0.1 port 8080. All right, this looks good. Next, let's call our main method and define it. So if name is equal to main, then call the main method, and we'll define the main method right over here. So def main, if the length of the command line arguments, so argv is not equal to 2. So if the user does not give the program the correct number of arguments, that means the user ran it incorrectly. So what we're going to do is we're going to print the usage instructions, which is the name of the program and URL. And the name of the program we take from the command line argument. We also print the example instructions. So example, name of the program, and a sample URL. So let's say www.example.com. And we take the name of the program from the command line argument. So argv0. Now, since the user ran it incorrectly, what we're going to do is we're going to exit the program. So sys.exit -1. All right, this looks good. Next, let's assume that the user ran it correctly. So the first thing we're going to do is initialize our sessions object. So requests.session. And then we're going to take the URL from the command line argument. So sys.argv1. And then we're going to call a function called exploit file upload, which takes in the session object and the URL. Now, this is a custom function that is responsible for exploiting the file upload vulnerability and then gaining remote code execution. And we're going to implement that function right over here. So def exploit file upload, it takes in the session object and the URL. All right, so if we go to repeater over here, what the function is going to do is it's going to perform this request, which uploads the avatar image, and then it performs this request to call the avatar image. Now, in this case, we're not actually uploading avatar images. Instead, we're uploading a PHP web shell. And if we look at the request right over here, you could see it's a post request to the /myaccount/avatar endpoint, and it takes in a bunch of parameters in a multi-part form. So the first one over here is the PHP script, which is this right over here. And then it takes in the user, which is the name of our user, and then a CSRF parameter. Now this CSRF parameter, we can't guess off the top of our heads. We need to retrieve it from the previous request of the application, which is this request over here. So if we go to /myaccount, which is right over here, and we search for CSRF, you could see that the CSRF parameter is in an input element that has the name CSRF, and the value that we want is in the value attribute. So we need to extract that value in order to perform the request. So that's exactly what we're going to do. We're going to say get CSRF token. This is just a comment. We're actually, before we do that, the first thing that we did is actually log into the application. So this is an authenticated vulnerability. You can't just get to the My Account page without logging in. So we're actually missing one request, which is this one right over here. So let's send this one to repeater as well. And let's just add a few comments so that it's absolutely clear. So this is login. This is upload avatar. And then over here, execute avatar, which is our web shell. So the first request we need to do is this one. So it's to the /login endpoint, and it also takes in a CSRF parameter. And this CSRF parameter over here is taken from this request over here, which is to the /login endpoint. So that's what we're going to do. We're going to say login URL is equal to URL plus the login endpoint, which is /login. And then CSRF token is equal to the value of the function get CSRF token, which takes in the session object and the login URL. So instead of implementing the logic for the get CSRF token right over here, we're going to create a function on its own because we're going to need to get the CSRF token not just for this request, but for the request of uploading the avatar user. So let's add a comment over here saying rest of code and implement our CSRF function. So def get CSRF token, it takes in the session object and the URL. We're going to say r is equal to s.get, so we're performing a get request to this login URL. And then we're going to set verify to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want our request to be sent to burp. And then we're going to say soup is equal to beautiful soup. r.text, which is the response of the request, and we're going to parse it using HTML parser. Now the CSRF parameter is going to be found in the request. So if we go back over here to proxy, we said when we looked for CSRF, which is right over here, when we looked for CSRF, it was in an input element. So we're going to say find it in an input element where the name of the element is equal to CSRF. So the name of the element is CSRF, and what I want is the content of the value attribute. So this has to be in curly brackets, and then we want the content of the value attribute. And that's essentially it. So we return CSRF, and when we return it, it gets saved in this variable right over here. So now that we have our CSRF token, we're ready to perform our first request, which is the login request. So let's remove this and say we're logging in as the regular user. So we'll print a statement saying logging in as the regular user. And we're going to save our parameters of the login request in a variable called data login. So that would be our CSRF parameter, which is equal to the content of the CSRF variable. And then we've got our username, which is just the username that we were given. And then the password, which is just the password that we were given. All right, this looks good. And then we perform a post request. It's s.post because it is, as we saw over here, a post request. It's to the /login endpoint, so login URL. Data is equal to data login, which we just defined. Verify is equal to false, and proxies is equal to proxies because we want the request to be sent to ver. All right, this looks good. Now we need to verify that we successfully logged in. So we're going to say if logout is in the response of the request, so r.text, that means we've successfully logged in as the user that we were given. If we don't see logout, that means we were unsuccessful in our login. So we'll print could not log in as the user, and we'll exit the program because this is an authenticated vulnerability. It requires that you properly authenticate to the application. All right, this looks good. So we've successfully performed this request. The next step is to perform the upload avatar request. So let's scroll up and say uploading URL over here and print a statement saying that we're uploading web shell. And to do that, we need first the URL. So if we go over here, the URL is the /myaccount/avatar endpoint. So we'll just say avatar URL is equal to URL plus /myaccount/avatar. And then we need all of the parameters over here in the request. And you could see over here, again, it takes in the CSRF parameter, which is taken in from the previous request. And if we go to the referrer header, we should be able to see the previous request, which is the /myaccount page. So the first thing that we need to do is actually retrieve the CSRF parameter. So we're going to say account URL is equal to URL plus the path to the my account page, which is just my account. And then after that, we'll retrieve the CSRF token. So we'll say CSRF token is equal to get CSRF token, which takes in the session object and the account URL. So right now, all we have to do is call our function, which we implemented right over here, and it'll retrieve the CSRF token from the /myaccount page. All right, this looks good. Now all that is left to do is define the parameters of the request and then perform the request. So we're going to say params is equal to the parameters of the request. So the first one over here was the avatar parameter. So let's copy that. Now this parameter over here takes in a file. So we're going to say the name of the file is test.php. And then the content of the file is this over here. So let's copy it, put it in here. And we're going to say the type of the file is this right over here. So the content type is application xphp. And let's put that in here. All right, so that's our first parameter. Our second parameter is the user parameter. So let's add that in here. And for this one, we just put the name of the user. And then we move on to the next parameter, which is the CSRF token. So CSRF, and the CSRF token is equal to the CSRF token variable that we just extracted over here. All right, this looks good. Now, if we were to perform the post request, this will appear as regular form parameters in the request. However, notice over here, it's structured in a multi-form format, where you have this string right over here, and then after the string you have a random set of 16 digit and alphabet string. And so what we need to do is we need to structure our parameters in such a way that they look exactly like this so that the request is accepted. Now, this string right over here could be anything as long as it's 16 characters and it's equal for each part of the request. And so that's exactly what we're going to do here. Let's go up. We're going to say boundary is equal to this over here. So let's copy it. And then we're going to add to it a set of 16 random alphabets or digits string. So we'll say random.sample string.ascii letters plus string.digits, and we want 16 of those, and that's essentially it. So it generates this string right over here, and then we're going to put this string right before each parameter. So to do that, we'll say m is equal to multi-part encoder, fields is equal to params, which we just created, and then boundary is equal to boundary. And then we're going to set our headers, which is essentially just the content type of the request. So content type is equal to m.content type. All right, and then we just perform the request. So we'll say r is equal to s.post. It takes in the avatar URL. Data is equal to m, so our parameters over here, but in the format that we want. And then headers is equal to headers. Verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want our request to be sent to Burp. And then we're going to print the following is the content of the secret file. So essentially we performed this request right over here. So now we only have the request to execute our web shell, and that's this request over here. So r is equal to s.get because it is a get request. It's to this endpoint right over here. So let's create a URL variable. Let's call it cmd URL is equal to URL plus the endpoint that we want for the request. Let's copy that, paste it in here, and take that as part of our GET request. So cmd URL, set verified to be equal to false, and proxies to be equal to proxies. And then we just print the content of the request, which is r.text. So all that essentially does is it prints the response of this page over here, which should be our secret key. All right, let's save this. Hopefully there's no errors. It is a pretty big script, and so we might have errors in it. Let's go to terminal, new terminal. And before we run it, let's open a new instance of the lab because this one likely timed out. And then let's say Python 3, file upload lab01.py, and the URL to the application. Let's copy it, paste it in here. And before we run it, let's open up Burp and look at the requests that it's making while it runs the script. So let's hit send. So far so good. You could see over here it logged in, and then it uploaded the avatar, and then it executed the avatar, and we don't get the content of the secret file. So something definitely went wrong. So if we look at test.php over here, you could see it does not have any content. And if we look at post.avatar and we go down, we've got our CSRF parameter, our username, and our PHP shell. And I know what's wrong over here. So over here, we just called test.php when we were supposed to call our CMD parameter as well, which I thought I did. So if we go down over here, we've got, and here we go. This is my mistake over here. So that should be CMD. And then the command that you want to run. So that would be cat /home/Carlos/secret. Hit save. So our script was just missing one component. Let's run it again. It should work right now and output the content of the secret file. And here we go. So if we copy this over here and click on submit solution, submit it over here, and it didn't copy right. Let's copy it one last time. Paste it in here, click OK. And here we go. It says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of a file upload vulnerability.